Okay. So so the first approach that I'll show you is, and I saw some of you guys using this approach. You've learned this before, and that's totally fine because it works. It's an iterative approach, or iteration is the process of doing that. Iteration just means do it again and again and again and again and again. Okay, so that's kind of what we're doing. So what we're going to do is you count the number and type of atoms in the products. Well, let's say reactants first because it comes first. Okay. And then if they don't equal each other, then you have to start change the coefficients until all atoms, well, let's say elements, that's better. Are balanced. Okay, and for those of you on the camera, I'm sorry that I'm writing backwards, but I did that just to make you angry. So I'm not sorry. I'm kidding. It's the camera. It flips the image. So, all right. So we just change the coefficients and balanced means that we have the same number on the left as we do on the right. Okay. And I like to do this with a table. I like to make a table. One column of the table is going to be reactants. The other column of the table is products. And then we're going to make a list of all the elements we have. We have carbon, we have hydrogen, and we have oxygen. Okay. So reactants, products, and then down the left side, these are the elements I'm dealing with. And now I just start counting, right? On the left side, I have one carbon. Products, one carbon. All right, it's balanced. I don't have to do anything yet. Hydrogen, 3 plus 1 gives me 4. On this side, I have 2 hydrogens. And then I go to oxygens. I have 1 here, but I have 2 oxygens here, so that makes 3 on the reactant side. And I have 3 on the product side. Questions so far? Okay. Now, is it balanced? No. What do I need to do to balance this? I need more hydrogen. How many more hydrogens? 2. So I can't change any chemical formulas. I have to change coefficients. So I already have 2 hydrogens there. If I put a coefficient 2, meaning I would end up with 2 water molecules, this gives me 2 particles, and each of those particles has 2 hydrogens. So that does give me 4 hydrogen particles in there. But it also gave me another oxygen. And so in my reactants, on my product side, I have 2 oxygens here and 2 oxygens there, which gives me 4 oxygens. So by fixing the hydrogen, we broke the oxygen, right? By fixing the hydrogen, we broke the oxygen. So we've got to fix the oxygen. How many more oxygens do we need? Where's the best place to get 1 oxygen? Right, over here. So if I put a 2 here, that will give me 2 oxygens on this side, plus 2 more right there, gives me 4. So now my oxygen is broke. It's fixed. But now I have 2 carbons over here. And when I had 4 hydrogens now, I have 2 of those, so that makes 8. So by fixing the oxygen, we broke the carbon and the hydrogen. So which one do you want to fix first, the carbon or the hydrogen? Carbon? Okay. We need 1 more carbon, so that's in the product side. So we're going to put a 2 there. That gives me 2 carbons. But now we have 2 more. Actually, there are 4 oxygens there and 2 oxygens there gives me 6 oxygens there. Hydrogens, I need 8. So this is going to have to be 4 because each one of those has 2. So there's 8 particles there. But now there are 4 oxygens and 4 more there. Gives me 8 oxygens. But wait, carbon's fixed, hydrogen's balanced, oxygen's the only one I need to change, and how many do I need? 4. Can I get just 4 oxygens?
Yeah.
Yep. How do I do it? Now, I need 4 more, and I had 2 there, so I need a total of 8. So there were 2 there. I need 6 more. So 3 particles of these 2 gives me 8. And now I have a balanced equation. Okay. So iteration, that means like every time we switch something and we broke something else, we had to go back and do the whole process again and double check our reactants and products. That's the process of iteration. Did we have to think too hard? Not terribly, but it took some time and took some doing. Okay. So, is there a more efficient way to do this? Perhaps. Okay. Can I erase this? I'll leave that table there so you can see it. Okay. The second way that we'll do, I like to call it an algebraic way. Okay. We use algebra. Okay. And the first step in that is to write equations for each element. Because we know that the number of particles of carbon on the left side of the equation has to be the same, has to be equal to the particles on the right side of the equation, I can write that mathematically. After I have the equations written for all of the elements, there are a couple of ways to proceed. Sometimes you can substitute equations into each other and find a single answer. I like to just start by assuming one coefficient. Okay, just start by picking one and giving it a name. It may be right, it may be wrong, but we'll just pick one to go from there. After we have that one, that should be enough for us to solve all the others. Now, the last thing that happens in this, we may end up with some fractions, and we want all whole numbers. So you may need to multiply all the coefficients by some common denominator. To get all whole numbers. Now this, sometimes you have to do it, sometimes you don't. So I'll write these down here so we don't forget them. So these are the coefficients we found. We'll do it the algebraic way, and hopefully we'll end up with the same answer. Okay. First step, write equations for each element. Okay. So for carbon, I forgot. We need to put variables in for these coefficients. Okay. I'll call this one A, B. I could call this one C, but I already have a C for carbon, so I'm just going to skip C and go with D and put an E there. So for carbon, there aren't any subscripts here, so whatever this number is, that's how many carbon atoms I have. Because if I have two, if this is 2, then I have 2 particles, and each particle has one of those pieces in there. So whatever that coefficient is, I have A atoms of carbon on the left side. Equals, on the right side, D. For hydrogen, each one of these particles has 4 hydrogen atoms in it. So I need 4 hydrogen atoms for each one of those particles on the left. On the right, each one of these particles has 2, so if E is 3, then that would be 6 particles. So I need 2 times that coefficient for hydrogen. And then for oxygen, I have one of those in there, so there's A plus each of those particles has 2, so that gives me 2 times that coefficient. And on this side, I have 2 times D. And on the that side, I also have E. All right. Questions about where these equations came from? Okay. Basically, we're taking the subscripts here, and we're multiplying the coefficients by the subscripts. Right. Let's pick a coefficient. Which one should we start with? A coefficient, A, B, C, D, E, or A, B, D, E. Pick A? All right, what number should we pick? Something easy. 2, okay. Now let's not pick 2, because that's what our answer is going to be. So let's pick 1. All right, let's assume... Okay. Let's assume A equals 1. Well, from this then, what does that tell us about D? So D is 1. And now I know what A is, so that's 4 times 1 equals 2E. So then I can divide both sides of the equation by 2, and I get that E equals 2. There's that one. And then down here, I know what A is. A is 1. I don't know what B is. D is 1. 2 times 1. Plus E is 2. Can I solve that for B? Yeah. Okay. So let's start by subtracting 1 from each side. 2B equals 4, 3. B equals 3 over 2. And those are my coefficients, except that I have a fraction. I need to get rid of it. So I have to keep all of the proportions the same. How can I get rid of that fraction? Multiply everything by 2. So 1 times 2 is 2. 3 over 2 times 2 is 3. 1 times 2 is 2. 2 times 2 is 4. Okay. So the algebraic way probably takes a little bit of practice. The iterative way takes a little bit of time. So I'll leave it up to you. You don't have, when I ask you, like for the test to balance an equation, I'm not going to ask you to show me your work. I mean, I'll leave space for you to do some work, but you can choose inspection, like if you can just look at it and say, oh, that's how it works, that's great. If you can use the iterative method and get it to balance, that's fine. If you can use the algebraic way to balance it, that's fine. I'm not going to specify what method you have to use. The thing that's important is that the outcome, 2 carbons, 2 carbons. 4 times 2 is 8 hydrogens. 2 of these times 4 is 8 hydrogens. Oxygen, I have 2 there, and 6 there gives me 8 oxygens, and 4 there, and 4 there gives me 8 oxygens. As long as the chemical equation is balanced, that's what we're interested in. All right?